Hello everyone, welcome back to Easy Physics with Omonye, where we make physics simple and fun to learn. In today's lesson, we will be looking at derived quantities and derived units, part 2. By the end of this lesson, you will clearly understand how quantities like area, volume, density, force, energy, and power are derived from basic units like mass, length, and time. If you haven't subscribed yet, please click the subscribe button. It helps this channel grow and ensures you don't miss any of my new lessons. All right, let's get started. Let's quickly look at our revision. That is what we did from our previous lesson. So from our previous lesson, we looked at the derived quantities and we said that derived quantities are quantities obtained by some simple combination of the fundamental quantities. We also looked at derived units, and we said derived units are units obtained by some simple combination of the fundamental units, that is the base units. Also, we looked at area, volume, speed, density, velocity, acceleration, force, weight, momentum, pressure, energy, work, and power as some examples of derived quantities. Let's quickly dive to what we will be starting with today. I want us to note, this is very important, let's note this, that the unit s to the power of -1 is read as per second. Let's break this down step by step for understanding. The S stands for second, the unit of time. That is the unit of time. The power of -1 means that it is in the denominator once. So S to the power of -1, which is equal to 1 over S, is read as per second. Similarly, the unit S to the power of -2 is read as per second squared. The power of -2 means that it is in the denominator twice. So wherever you see s to the power of -2, which is 1 over s to the power of -2, is read as per second squared. Moving ahead, we will look at derived quantities and derived units. Clearly, we have a table. The first column says derived quantities. The second column says derivation, how these quantities have been derived. Finally, we have the derived units on the last column. For the first, we have area. Area, the derivation is length times breadth. We all know this. Length is in meters, breadth is in meters. That is why we have the derived units as m to the power of 2. That is m squared. Volume. Volume is derived by length times breadth times height. Length is in meters, breadth is in meters, and height is in meters. That will give us m times m times m, and we will have m cube as the derived units. Density. Density is mass over volume. Mass is in kilogram. Volume is in meters cube from the above. So taking meters cube up, we'll have m to the power of -3. That is why we have densities derivation, that is the derived units under density, as kg m to the power of -3. So going ahead, under derived quantities and derived units, still, we have that of speed, velocity, and acceleration. So for speed, under derivation, speed is distance over time. And we know that distance is in meter and time is in seconds, hence the derived units, ms to the power of -1. For velocity, the derivation, velocity is displacement over time. We know displacement is in meters and time is in seconds. So that's how we have ms to the power of -1 under the derived units column. Acceleration is change in velocity over time. Change in velocity, from the above, we can see that velocity, the derived unit for velocity is ms to the power of -1. We'll substitute this into acceleration over time. Time is in seconds. Now, taking time over again, we now have ms to the power of -2. Forging ahead, still under derived quantities and derived units, we have force, weight, and momentum. Force is mass times acceleration. When we substitute this, we'll get our derived units as kg ms to the power of -2. Also, weight. Weight is mass times acceleration due to gravity. Substituting, we'll have what we have under the derived units column. Finally, for momentum, which is mass times velocity, substituting, that's what we will have. If you have any question, kindly drop under the comment section. So for pressure, pressure is force over area. When we substitute, that's what we'll have. Same goes for energy or work and power. Don't forget, if you have any question, ask under the comment section and then I'll respond to your questions. Let's quickly look at pressure, how pressure was derived. So you could substitute for energy or work and power and see how it works out. So for pressure, pressure is force over area. Let's do a step-by-step breakdown. The unit of force is Newton. From physics, let's note that 1 Newton is kg ms to the power of -2. The unit of area is squared meter. Now let's substitute these two into the pressure formula, which is force over area. We'll have what we can see clearly. And when we strike out, at the end of the day, we have kg m to the power of -1 s to the power of -2. This is also written as Newton meter per second squared, which is also called the Pascal. Do not forget